Very good morning to one and all present in this 2 days International Conference on Science and Technology Research ICSTR, which is being held in the Tokyo, Japan. I would like to thank the organizer for inviting me to deliver a talk on fuzzy logic and its application in artificial intelligence. I would like to welcome all the participants who are being here in this 2 days international conference. I am Dr. Manoj Sahni, an associate professor and head in the Department of Mathematics at Pandit Deendayal Petroleum University, Gandhinagar, Gujarat, India. So, my contents of the talk will be a brief introduction of the set theory, then how the transformation took place from the set theory to the fuzzy sets, and I'll give you some examples related to the fuzzy sets. What are the requirements that is being generated that the fuzzy sets development took place, and I will give you the difference. What is the difference between the crisp set and the fuzzy sets with the representation, and then we will move on to the fuzzy logic part. Then why do we use fuzzy logic and what are the applications of the fuzzy logic in artificial intelligence? And at the last, we're going to conclude, and with the references, we're going to stop. We all know that the development of the set theory is given by George Cantor in 1870s, which is of great importance in mathematics and is based on the law which we call it as the law of excluded middle. Now, what is law of excluded middle? It says that a proposition can be either true or false, or it can be represented in the mathematical terms, that is 1 and 0 respectively. Membership functions, that is nu of x, nu of ax, can be defined as 1 if any element x belongs to the set A, and 0 if x does not belong to the set A. That means it is in the form of a binary, that is zeros and 1. Now, this is a classical set theory, which we also call it as a crisp set. Okay, now we're going to discuss, because these are the qualitative words, a tall, or you can say that is large, high, moderate, very high, very low. These are all linguistic variables which the set theory given by the George Cantor will not be able to cater the situations which we are talking about. So in that case, the approach being developed by one of the great person, that is Lofty-Zadeh, in which the fuzzy sets came into existence. What is actually a fuzzy set? In fuzzy, we can call it, in a simple English language, it is an imprecise or not clear. Okay, now what I'm talking about, this is a person who is actually the architect of the development of the fuzzy set theory. Okay, in 1965, he has given this concept and a lot of papers and the application shown by this scientist. Okay, so few of them like fuzzy sets in the information and control systems. Fuzzy sets as the basis for a theory of probability in the fuzzy sets and system. So these are some of the basic papers by the Lofty-Zadeh, and I request you that you should read those papers. Okay. Now, this with the initial development of fuzzy set theory, there is a sharp criticism by the government as well as by the research community. But Lofty-Zadeh has not given up, and he has shown that there is a lot of applications of the fuzzy set, that is applications of the fuzzy set which is being used in various fields of science and engineering. So he has shown in the 1965 to 1975 the applications, as well as he has also developed this theory. The applications he has shown in the decision making, okay, and the development took place related to it that is fuzzy similarity relations, restrictions, linguistic hedges, and by seeing the popularity of the fuzzy set theory, a lot of research peoples start actually accepting this fuzzy set theory, and a research group in 1970 has been formed in Japan. Now, this conference here is again in Japan. So, a fuzzy set theory has been accepted all over the world, and now there is a boom that is going on in the fuzzy set theory. So, there are a lot of allied related to the as well as the extensions of the fuzzy set theory that is going on. Okay, so as you can see the history of it, that is in 1974 Mamdani in UK developed the first fuzzy logic controller, and in 1977 Dubus applied fuzzy sets in a comprehensive study of traffic conditions. Similarly, in the interval from 1976 to 1987, a lot of industrial applications of fuzzy logic in Japan and Europe has been shown. And from 1987, there's a boom that came, and many researchers across the globe has started accepting and working on it. So this is a small history of the fuzzy logic. Now, as I said to you, fuzzy is actually in simple English language means not clear and noisy. Okay, a simple example to make you understand is that this is a set, okay, that is X having the rhombus shape, that is a triangle shape, hexagon, square, circles, and all those. Okay. Now, if I ask you to define a set of circles and form a set having these circles, then you will be putting what? A small circle, a middle, and the bigger circle. So in that case, you have taken only the shape of a circle and no other elements come into that. But in the case of fuzzy, if I ask you to put the circles, then in that case, you will be assigning the membership value to each of the elements present in the set X. So as I take into consideration the hexagon, the membership value is being given as 0.1. Okay, that is very far from the circle. Similarly, if you increase, that is, if you take the octagon, then it is approaching towards the circle, the membership value is increased to 0.3. And similarly, if you increase the sides of the polygon, then the membership value will going to increase. And when it moves exactly to the shape of a circle, then a membership value 1 is being assigned to each of the circle. So that is the difference between the Cripps definition and the fuzzy. So fuzzy, in which we assign the membership value between 0 and 1 in the closed interval. Okay. So as you can see it here, that is the T actually belongs partially to B, where Z belongs completely to B. Okay, and Y belongs completely to A, and X belongs neither to A nor to B. Okay, so that means there is an ambiguity if I take into consideration the element T, but not for X, Y, and Z. Okay, so this is the representation. On the left hand side, if you see the figure, that is the graphical representation of the Cripps set, that is the membership value is either 0 or it can be 1. But in the graphical representation on the right hand side, C is neither belonging to the set, okay, nor it is outside the set. So that is at the boundary. So we cannot put into consideration 0 and 1 membership value. So that is why we have given 0.5 membership value. Okay. So if I ask you here a number close to 5, then 4 and 6 are close to 5. In that case, 4 and 6 is being given the membership value as 1, and all other value, that is, if you move lower to 4, then you will be getting the membership value as 0, and above 6 you will be putting again the membership value as 0, which can be represented in this form. Okay. Similarly, on the right hand side, that is, this is in the triangular form. So this is a membership value that we have not defined 0s and 1, but between 0 and 1. Okay. So that is the difference between the crisp and the fuzzy set. Whereas a crisp, it's a collection of elements, whereas a fuzzy, it is a collection of ordered pairs. Okay. Now, the membership value in the case of a fuzzy set is being defined from the elements of the set to the intervals. Okay, so mu of a x is actually the membership function. Okay, so as I have given you the example before, that is, there is a list of 10 peoples who have the heights in centimeter defined from 152 centimeter to 208 centimeter. If I define it in the form of a crisp, then above 181 is being defined completely as 1, whereas if I take into consideration, so that is a logical thinking, above 180, above 180, then in that case, if you define it using the crisp, then you will be getting the membership value as 1. So is 180 the height which is not tall? No, not exactly. The human thinking never accept that. So in that case, we define a membership value, that is 181 has been defined as 0.82, 198 has been defined as 0.98, and above 198 is being defined as 1. So if I represent it, that is the second figure, that is which is written as fuzzy set, is in the form of a continuous function that is not discrete. Okay, so the membership functions is a very important criteria to define in the case of a fuzzy sets. So there are various ways. One is called as the machine learning methods, that is artificial neural networks, genetic algorithms are there to define the membership functions. Okay, so there are many membership functions that is being available. Okay, and that is already being defined by researchers for different applications. Some of them are triangular, trapezoidal, piecewise linear, Gaussian, sigmoid, and there are many other functions that are also used to define the membership values. Okay, so some of them that is being listed here is the first, that is in the form of a trapezoid, so it is called a trapezoidal membership function. Similarly, the second is a triangular membership function, that is in the form defined as triangle. Okay. The third one is the very commonly used is, which we call it as Gaussian membership function. Okay, normal distribution. Now here C, S and M will going to, whenever the C, S and M will going to vary, the membership values will also going to vary. Okay, so for different CSM, the different Gaussian functions are being formed, as you can see on my slides. Okay, so this is the representation. The top in the summation form is the discrete representation of the membership functions, and the integral form is the continuous form of a membership function. Now, I'm coming directly to the fuzzy logic. Now, what is fuzzy logic? Now, this is a method of reasoning that resembles human reasoning. The whatever we think of, okay. Now, fuzzy logic is very similar to it. Now, as I say that if I say in the crisp set, is it cold? Then what does the answer will be? Yes or no. That is 1 or 0. Yes or no means that is 1 and 0. That is Boolean way. Now, is it cold? What does the human think? Very much, little, very less, much, very less. So these are the all linguistic variables. Okay, that is actually given the membership functions 0.9, 0.25, 0.1. So you can also define the membership functions between very much and little. So this is a fuzzy way of thinking it, which is very near to the human thinking. Now that is always imprecise, that is not always exact, and it cannot be exact, but it is very similar to the human thinking. So that is why it is being acceptable to the research community. Okay, now if I have to use the fuzzy logic, then in that case we need to define the operations also. So there are some operations that is being defined in the case of fuzzy logic, that is in the crisp we define AND, that is the Boolean way. Okay, and similarly in the fuzzy, that AND is replaced with minimum, and Boolean way if I define OR, then in the fuzzy way it will be changes to maximum. Okay, and if the Boolean way we define NOT, then it will be 1 minus x. So these are and or not, which is not available, but in the case it is min, max, and the difference. Okay, so we'll be using the operators min, max, and the difference one. A very simple example to make you all understand how does the fuzzy logic works in the artificial intelligence. Okay, so the convention model in the controlling of a fan, if the temperature is greater than X, then the fan should run, otherwise we're going to stop the fan. So there are only two ways, that is on and off. Okay, but in the fuzzy system, the temperature around our surroundings can be represented in the form of hot, warm, comfortable, cool, cold. So in that case, the human thinking is that our fan will adjust according to the temperature of our environment. So if the temperature is equal to hot, then we have to run the fan at full speed. If the temperature is equal to warm, then our fan should run at moderate speed. Okay, so like this, it is comfortable, then we have to maintain the fan speed. If it is cool, then we have to slow down the fan. And if the temperature around our surroundings is cold, then we have to stop the fan. Okay, so this is a very common common thinking of a human, and the fuzzy system resembles. Now, if you understand this, then our some rules that is being formed, then that rule, if you see, it is in the form of if then, which the fuzzy logic take into consideration. Okay, so why fuzzy logic? First thing is, it may not give us accurate reasoning, but it provides us with acceptable reasoning. What I said to you, that it is very near and dear to the human thinking. Okay, so this is why this is the most important thing that we should understand. Second, information is often imperfect. It cannot be exact, and data has errors. Always the data has errors. So by replacing binary either or operations with if then possibilities, here in the fuzzy we replace what, either and or with if then. Okay, so in that case, the fuzzy logic takes into consideration the linguistic variables such as short, medium, tall, moderate, very high, high, like this. These are the terms which we call it as linguistic variables. Okay, now linguistic variable is a fuzzy variable. Okay, so if wind is strong, then sailing is good. So what are the rules, that the fuzzy logic rules, that is if then rules, and we're going to see it in the one examples that we're going. Now fuzzy logic controller, now which we also use it in various applications, like in the washing machine we use it, in the air conditioner we use it, in the IP camera we use it, that is internet protocol. So there are various applications of the fuzzy controller. These are all artificial intelligence that we generally use it, and that is being a part of a human life. Okay. So what is artificial intelligence? Now this term artificial intelligence was actually coined way back in 1956 by John McCarthy, that is a professor at Dartmouth. Okay. Now, if I need to define it in a very simple language, artificial intelligence is what? It is the simulation of human intelligence. Okay, and this simulation is done by the machines. Now, who programmed that machine? That is programmed by the user, that is by all of us. Okay, so the machines need to learn how to reason and to do self-correction as needed along the way. Okay, so there are many algorithms that is being available to actually program the machines which work according to the human thinking. Okay, so that is called artificial intelligence. Now, what is fuzzy logic system? Fuzzy logic system have three components. One which we call it as a fuzzifier. Second, which we call it as a linguistic inference, that is the intelligent part which contains the rules. And the third is a defuzzifier. Now, how does it work? It works, there is an input, okay, that is being given by the user, and the fuzzifier fuzzifies that input, which goes into the second part which we call it as a linguistic inference. And here the processing is being done, that is the arithmetic work that is being done in this component, which actually fuzzifies it, okay, mathematically manipulate it, all the work that is being done in this, the rules that is being applied to the inputs, and then we will be getting an output in the form of a fuzzy, which actually in the third component, that is defuzzifier, defuzzifies it, and we will getting an output in the form of a, which we call it as a crisp value. So I will make you understand what it is. First is it contains all the rules and the if-then conditions offered by the experts to control the decision-making system. Okay. Now this fuzzification, this step converts inputs or the crisp numbers into the fuzzy sets. Okay. Now inference engine is doing what? That is the processing part. So it determines the degree of match between the fuzzy input and the rules. And then the defuzzification is done at the last step. Okay. Now a simple example to make you, that is air conditioner. Now air conditioner is actually being used in such a way so that the temperature of the room is being maintained. Okay. Now I'm giving you an example of a 5-level fuzzy logic system. How does it work? Okay. There's an input, okay, which goes to the fuzzifier, which moves in the inference engine, and that inference engine contains some rules which defuzzified it, and you will be getting the answer in the crisp form. Okay. So what I said, it's a 5-level. So we define the temperature in the form of very cold, cold, warm, very warm, and hot. So that is the 5-level fuzzifier. Okay. Now this 5-level fuzzifier can be written in the form of, that is the input temperature, as you can see, that is LP, it is hot, MP, that is very warm, S, that is warm, cold, that is MN, and very cold, that is N. Okay, so this it is represented in the form of a membership function. Now this membership function, as you can see, it is in the form of a triangle, so it is called as a triangular membership functions. So the most important thing is to define the membership functions. So there are various ways to define the membership functions. Okay. Okay. So the third is how to construct knowledge-based rules. So the knowledge-based rules, if you see the room temperature and the target. So the room temperature is very cold and our target is again to maintain the very cold. So in that case, there is no change that we require it. Okay. Similarly, if the room temperature is very cold, but our target is cold, then we have to heat it to get the target temperature as cold. Similarly, if the room temperature is very cold and we require warm, again we need to heat it. Okay. Similarly, if the room temperature is very cold and again we require the hot and very hot. Okay. So that means we need to heat it. So these are the rules that we need to form it. Okay. Now how it is being formed? That is in the form of if then. Now see in my next slide, if the temperature is cold or very cold and the target is warm, then what will be the action that we need to take it? That is heating off. Heating should be done. If the temperature should be hot or very hot, then what will be our target? Then what will be our target? That is warm. And in that case, what will be the action should be taken? That it should be cool. So these are the fuzzy inference rules. And using this, okay, and using this inference rule and the operators that we're going to use, that is the max and min, okay, which will provide us the fuzzified value, okay, which will again be defuzzified in step number 5, and we get a crisp value. That is one value that we'll be getting it, which we call it as a crisp value. So this is the 5 steps that we need to follow it for any process, for any fuzzy controller. Okay. Now, because of the shortage of time, I'm extremely sorry. I would like to list you few of the examples of the fuzzy logic which is used as an artificial intelligence in various applications. That is, fuzzy logic is also used in the development of autonomous vehicles. Okay. Where the speed control, steering wheel control, and adaptive cruise control are very important. Okay. So that all being controlled by the machine itself. There is no human intervention. Okay, so I'm not going into the depth of it, but that is one of the applications of fuzzy logic, the artificial intelligence. Okay, again there is a rules that is being formed, then there will be inference which uses the max and min operators to convert the to convert it into the fuzzified value, which again defuzzified and will give us the value. Okay, now fuzzy logic is also used in the washing machine, that is it is a part of artificial intelligence. Okay, so what will be the input here? That is the type of dirt and the dirtiness of the clothes. Okay, so depending on the type of dirt and the dirtiness of cloth, the output, that is the washing time, how much time that is being used to wash those clothes, okay, that is the output, is dependent on the type of dirt and the dirtiness of cloth. That is an input. Okay, so there is a process, as you can see, that is the input is type of dirt and the dirtiness of clothes, and that will be fuzzified, which goes into the inference engine, that is where the fuzzy arithmetic and applying criterion that is being done, which is defuzzified, and after defuzzification you will be getting an output which is in the form of a washing time, okay, which is a crisp value, as I told you. Now this fuzzy logic is also used in the vacuum cleaner, in the camcorder, in the IP camera. Okay, there are lots of applications, not one of them. So what are the advantages of the fuzzy logic? Now fuzzy logic provides simple reasoning similar to the human reasoning. The structure of fuzzy logic system is easy and understandable. It is widely used for commercial and practical purposes. It helps you to control machines and consumer products. Okay, it helps you to deal with the uncertainty in engineering, which is not possible using the set theory. Okay, and there are lots of advantages. There are some disadvantages, that is fuzzy logic is not always accurate because we are dealing with the uncertain environment. Validation and verification of a fuzzy logic based system needs extensive testing with hardware. Okay, so setting exact fuzzy values and membership function is a very difficult task. Okay, and fuzzy logic is also confused with the probability theory. So these are some of the disadvantages of the fuzzy. Now I would like to conclude my talk. That is, because of the rapid development of modern information technologies, it is possible today to collect, store, transfer, and combine huge amounts of data at relatively low cost. So, however, exploiting the information contained in those data archives in an intelligent way turns out to be very difficult. So, however, in order to get truly useful results, we must take into account background knowledge, non-numerical information, and uncertainties. And we must focus on comprehensive models. So fuzzy logic helps to make a link between traditional knowledge driven approaches and purely data driven ones, because aspects of knowledge representation and reasoning have dominated research in fuzzy theory for some time. Fuzzy logic, with its ability to handle uncertainties, has been widely applied to many engineering and scientific tasks. So the examples of it are air conditioner controllers, washing machine, speed control module in a self-driving car, and IP camera show us how fuzzy logic can be applied to systems. All in all, fuzzy logic is not only a theory but another way to look at the world. Fuzzy logic presents practical ways to solve many problems in various fields. Answer does not always require complicated equations. Sometimes it just needs some common sense and a little fuzzy thinking. So if anybody is interested, please refer to those references. By first is the Zadeh fuzzy sets in the information and control systems. There's one very good paper, that is, does machine learning need fuzzy logic? Then the other is the fuzzy control programming technical report, fuzzy logic systems for engineering, and there are many papers and books that is being available on fuzzy systems. Now I would like to end my talk by quoting That is, as far as the laws of mathematics refers to reality, they are not certain. And as far as they are certain, they do not refer to reality. So thank you all for patiently listening. And if somebody wants to contact me, then he or she can contact me on my email address, that is manojsahani117@gmail.com. And if anybody would like to collaborate with me, so please write a mail. I am ready to collaborate with the esteemed researchers who are here, who are patiently listening to me. And at the last, I would like to thank the organizers for inviting me to deliver a talk. Thank you so much.